and good morning. We are starting on day 2 of lesson 26. And this is going to be pretty quick and pretty straightforward about what you're going to need to do. You are going to be doing problem D and E today, and more practicing if you'd like to with these kinds of problems, but you're going to be doing D and E today. And also number 2, which we're going to talk about in just a moment, but you're going to work problem D and E the same way you did yesterday and see if you can come up with the difference between those two for this problem and for this problem. And then you have to come down to problem number 2, which is going to be a tiny bit more interesting. All right, so let's take a look at what's happening on problem number 2. It says that Tanisha and James drew models on their place value charts to solve 102 take away 47. You have to tell whose model is incorrect, in other words, which one is wrong, and you also have to tell why. So this is James's model, and this is Tanisha's model. So it says, oh, my math is sick. So you're going to say either James' model is incorrect and then say why, because, or you're going to say Tanisha's model is incorrect and tell me why. Now I'm going to give you a little hint on what you could do to make this problem work a little bit easier for you. You've probably seen Mrs. Mulder use this hundreds chart before. So what I would do is I would show James's work. So here's my model for James. And I would write everything down that you see on this model here and see if you can figure out if he's on the right track for what he needs to do. And then I would also do the same thing with Tanisha's model. And I would copy down exactly what she did in this fashion and then compare the two to decide which one of these two students is incorrect. If you will do that, I think you will find that this problem is a lot easier to do. You're going to be showing the vertical model and compare that with the chip model. And I think you'll see very clearly which one of those students is incorrect. So that's what you're going to do on problem number 2. We've done these kinds of problems before, but you just need to make sure that you study very carefully what those two students are doing. Also, my friends, when you finish with that, you're going to check your work with me, and then, of course, you are going to send your exit ticket to your teacher of these two problems, showing all the steps that you have taken to demonstrate your understanding of what we did with decomposing tens and also hundreds, which don't always happen at exactly the same time, but you need to look carefully to see which one is which. All right, so with that, I'm going to ask you to pause your video. Make sure if you need to, you can always go back and watch the video for 26 again if that's helpful to you. And with that, you are going to solve these problems. And I'll see you in a few minutes. Are you back? All right, so let's go ahead and start with 115. And we are going to take away 26. 115 take away 26. We are going to take a good close look at our whole here, and we are also going to represent that whole in our chip model. So I am doing that right now. Sorry, we got a little, here we go. Sorry about that, my friends. Okay, so we are back. Mrs. Kissel is done talking to us. So I have 100, 110, and 111, 112, 13, 14, and 15. I am going to be taking 26 away from 115, and the first question that I want to ask is, looking at my ones, can I take 6 ones away from 5 ones? 1, 2, 3, 4, 5. Nope, I can't. I don't have enough. So I know that I'm going to have to decompose a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm decomposing that 10. And if I make a change here, I also have to make that change in my vertical form. So do I still have 5 ones? Oh, no, I don't. I don't have 5 ones anymore. I now have 10 ones plus 5 ones gives me 15 ones. And do I still have 1 10? Well, nope, I don't. I have 0 10s now. All right, so now I'm going to come back and I am going to take a look at what's going on in my ones. So 6 ones from 15 ones. Well, I think I can do that now. 1, 2, 3, 4, 5, and 6. So I'm taking 6 ones away, which leaves me with 9 ones here and 9 ones here. Remember, if I do it in my chip model, I also have to do it in my vertical form. So now I'm coming over to the 10s, and I'm looking at my 10s, and I see that I have 2 10s take away from 0 10s. That could be a problem because I have no 10s here. What am I going to do? Well, I know that I've got some hundreds here. Here it is right here. At least I have hundreds in 115, but not in 126. I think I could decompose that 100. So I am actually going to be decomposing both a 10 and a 100. So here comes my hundreds. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I've got 10 10s, 10 10s. And if I make the change here on my chip model, I also have to make the change in my vertical form. Do I still have 0 10s? Well, nope. Now I have 1 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s, 8 10s, 9 10s, and 10 10s. I'm just going to make that into 10 10s instead of 0 10s. And do I still have a 100? Nope, that's gone too, and now I have 0. It didn't really go anywhere, it just moved. But I don't have anything in the hundreds place. So now, can I take 2 10s away from 10 10s? Well, let's take a look at that. 2 10s going away, 1, 2, leaves me with 8 10s. So 8 10s and 9 10s. Don't forget to put it in your vertical model, Miss Star. So 10 10s. Oh, sorry, I got myself off just a little bit. 10 10s take away 2 10s is 8 10s. 8 10s and 9 1s gives us the standard form of 89. So 89 is my standard form, and there it is right there. So congratulations. Oh, wait a minute, I'm not done. I need to look and see if I have any hundreds left. 0 100s, take away 0 100s is 0 100s. Still going to be 89. All right, so now let's come over to letter E. We have 110, take away 74. 110, take away 74. I am going to take a close look at my whole here and represent it in my chip model. I have 1 100, 1 10, and 0 1s. So I am going to look to see, as I'm thinking about this, can I take 4 1s from 0 1s? Nothing there. Got to do something because I got to take away 4 1s. So I'm going to decompose a 10, and I hope you did too, to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm decomposing that 10. And if I do it in my chip model, I also have to do it in my vertical form. So do I still have 1 10 left? Nope, I don't. So that's giving me 0 10s. And how many 1s do I have now? Do I still have 0 1s? Nope, I don't. I now have 10 1s. So I'm going to cross that out. And I think I'm ready to continue on. 10 1s take away 4 1s. Can I take 4 1s away from 10 1s? Well, let's do it. 1, 2, 3, 4 leaves me with 6 1s. If I do it in my chip model, got to do it in my vertical model. Okay, so I've got 6 1s, but now I have 0 10s. Look over here at my vertical model. I've got to take 7 10s away from 0 10s. Do I have enough? Oh, heavens to Betsy, no. I am going to have to decompose 100 so I can get those tens. Here we go, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I've got 10 tens. Do I still have one 100? Nope, I don't. I have 0 100s. Do I still have 0 tens? Wait a minute, I just decomposed or unbundled a 10, so now I have 10 tens. There it is, so I have to show it in my vertical model. 10 tens take away 7 tens. Well, let's take away 7. 1, 2, 3, 4, 5, 6, 7. How many tens does that leave me? That leaves me with 3 tens. So whatever I do in my chip model, I have to do in my vertical form. 3 tens and 6 ones in standard form would be 36. All right, so now I'm going to sneak over to this little problem down here, and I am going to show you what happened here, and then you can look and see how you did with yours. So James set up his problem with 102 take away 47. He says that the answer is 55 as he goes through all of his steps. Tanisha, she sets up the same problem, but she says that her answer is 95 because she still sees that she's got 1, 2, 3, 4, 5, 6, 7, 8, 9 tens left. Well, who is correct? Is it James or is it Tanisha? Well, I think Tanisha forgot to do an important part, which was to take away those 5 tens, to take away those, those 4 tens, these 4 tens right here. I think she did not do that, which is why she ended up still with 9 tens. So I would say that Tanisha is the one who is incorrect. So Tanisha forgot to take away those 4 tens from the 9 tens. She just left them sitting up there, and that's why she ended up with 95. So if I was going to be doing this, I would say that Tanisha's model is incorrect because she did not take 4 tens from 9 tens. There you go. Alrighty, so with that, now you are going to move on to your exit ticket, do both of those problems, and send that to your teacher. And with that, I am going to tell you to have a great day of learning.